Hey everyone, thanks for joining this session. So tonight we're going to talk about machine learning engineering career. I'm assuming you're interested in, ML ops and ML engineering. Hopefully, I can, provide some useful information in this session. First of all, I would like to share some resources with everyone. If you would like to stay in touch and get access to the recordings of WeCloudData's, live events and workshops, you can join our Discord channel. We also recently launched WeCloudOpen, which is an open course. So we have open workshops. We also have free SQL and Python courses. If you're just trying to get into the data industry, I think our SQL and Python courses are very useful. So take advantage of it. And we are also running the live classes this week and next week. You should be able to find the details on our website. Just go to weclouddata.com/wecloudopen. You'll get all the details. And most of our event recordings will be uploaded to YouTube as well. So you can go to youtube.com/@weclouddata. And yeah, we also have a machine learning engineering bootcamp. So if you would like to learn more about how we help students get jobs in ML engineering, you can check out the page. And if you're interested, come and talk to us. Okay. This is an interactive session. So I would love to get your input on some of these, discussion. I'm not just going to provide the answers, right away. I'd like you guys to be involved. So feel free to unmute yourself or send your comments to Zoom chat. And yeah, let's talk about ML engineering. We'll go through, ML engineering career, because there might be some confusions around, what is ML ops, MLE, the difference between machine learning engineer and data scientist. ChatGPT seems to be very promising, and it's going to have a pretty big impact on some of the job categories, I would say. But people are kind of worried about, jobs being, ML or whatever software jobs being taken away. I don't think that's going to happen, but we can talk about it. I'll share my opinion on this as well. And then we'll talk about the learning path. I think everyone in this event today will be interested in learning more about the things you need to learn to become a ML engineer. I would like to talk about some of the project ideas as well, whether it's, building portfolio projects or building real hands-on experiences. And we'll leave some time for questions, okay? First of all, what is machine learning engineer, or what is machine learning engineering? Do you guys have any input? What do you think is an ML engineer, and what is the difference between ML engineer and data scientist? Any thoughts? I think machine learning engineer is relatively new job title, right? Because in the last 10, 12 years, data scientist has been such a popular job category. And the data, I think in general, is growing really, really fast. And data science is getting more specialized now. So there are data analysts, right? Data scientists, data engineers, and now machine learning engineer. Okay, so Jessica said machine learning engineer is more ops, and data scientist
is more.
Yeah. Go ahead. Oh, sorry. Someone, is it Rohit? We can't hear you. I could hear for a sec.
No, I didn't talk. I think somebody else was trying to say something. Yeah,
Okay.
I typed my own say.
All right, cool. Yeah, so Jessica said in the comment that machine learning engineer is more about operations, and data scientists are more analytics. Yeah, I agree with this. I think that's one of the main distinction between ML engineers and data scientists. I think data scientists will definitely focus more on the predictive analytics side. I think that they share a lot of things in common, right? Because before MLE positions exist, people are either called machine learning researcher or machine learning scientist or data scientist. Data scientists will be building machine learning models, predictive models. But I think for data scientists who specialize in machine learning, especially natural language processing, computer vision, they are more called like a machine learning engineers now. And MLE focus more on deploying things in production, right? It's not just training and tuning the models, even though in some companies, machine learning engineers actually just work like data scientists. But in many companies that we have worked with or we have talked to, I think machine learning engineers work more like ML ops. So there's a little bit confusion here. Sometimes in some companies, machine learning operations and MLE are basically the same position, or one person will need to sort of do everything. But if you look into like MLE, MLOps, it's there are a lot of things you need to know. So there's also some sort of specialization there. But definitely machine learning engineers will need to understand how to do model serving and how to save models and how to deploy models in production. MLOps can focus more on the infrastructure side, CI/CD pipelines. So more DevOps involved for sure. But data scientists, I think they definitely need to know machine learning as well, but they don't necessarily always work on the production side. But data scientists will definitely be doing a lot of the experimentation, right? In production. Okay. And any comment on ML ops and machine learning engineering?
Is MLE more towards deployment and ops more towards infra development?
Can you repeat the
Yeah,
second sentence?
I said ops is more towards developing the infra for the deployment, or development or deployment.
Yeah,
It's
so
something like how a DevOps like a developer and probably somebody who would work on how to seamlessly integrate different developers, their work, and say do automation, CI/CD pipelines, and those things.
yeah. So machine learning engineers will focus more on deploying models, right? They also need to sort of automate pipelines, ML pipelines. They will need to work on scaling your modeling pipeline as well. But when you look at a machine learning project, when you deploy that in production, obviously you need DevOps or people who know DevOps to maintain infrastructure and also help build CI/CD pipelines. So that's more on the operations side. So it's kind of like software engineers working with DevOps, but in the machine learning side, it will be machine learning engineers working with MLOps. But to be honest, if you see a job posting saying that it's a machine learning engineer, you'll notice that the job description pretty much asks for everything. So they're looking for people who know both machine learning engineering and MLOps. Of course, some companies, these are very different roles, but I've seen many companies like posting a job that basically requires not only machine learning engineering, deployment, software engineering, as well as DevOps as well. So we're going to talk about the machine learning engineering learning path. Oh, sorry. Yeah. Generally, I think if you would like to learn the technical, skills and tools about machine learning engineering and MLOps, we'd like to break that down, into 4 different categories. There's the data engineering part, because it's always garbage in, garbage out, right? So getting the data right is important. There are obviously data engineers supporting this, but a lot of times machine learning engineers actually need to work on the data engineering side as well, or the skill set definitely overlap. And machine learning engineers will definitely be focusing more on the machine learning side, right? Whether it's scaling your modeling pipeline, or tuning the models, right? And also deploying the models as well. On the software engineering side, when you do the model serving in production, then you actually need to know how to work with microservices, need to understand how to deploy things in production. So you need to have a pretty good understanding of the software development lifecycle, be able to write more code basically. And on the DevOps side, and of course, infrastructure, right? Working with Terraform, launching, for example, Kubernetes clusters, building CI/CD pipelines, working with GitHub Actions or code deploy tools in AWS or Google Cloud. And also a big part of DevOps is the monitoring, right? But it's not just application or infrastructure monitoring, it's also the machine learning system monitoring. So I think that machine learning engineers will definitely work closely with DevOps or MLOps team to sort of define, model drift, data drift, or feature drift. So it's not just application, data tracking and monitoring. It's also the ML model performance and feature drift, monitoring. You might be using similar tools such as Prometheus and Grafana, but ML engineers will probably be also working with ML tracking tool, such as Evidently or some other tools. So looks like machine learning engineers will need to be pretty well-rounded, and it's still kind of hard to define, what exactly is MLOps, because for some companies it's basically just MLE, but for some companies it's actually DevOps who need to know a little bit more about machine learning, but they don't really need to come from a machine learning background. But yeah, the way we teach machine learning engineering is that we include MLOps in the curriculum. So students will need to learn machine learning engineering, deep learning. They need to have a pretty good understanding of deep learning as well. And then we'll teach students the software development skills and DevOps skills that they need to work in MLOps as well. Okay, so I actually have some slides. I'll quickly go through these, and thanks for all of your input. Okay, so I think this is probably what most of the data scientists, how they understand machine learning, right? Because they tend to spend more time in the Jupyter Notebook environment, doing all kinds of experimentations, right? Working with MLflow to keep track of their model experimentation. And their code is mainly, code written in the Jupyter notebooks using Python, working with, scikit-learn, PyTorch, TensorFlow, right? Or maybe pandas doing data manipulation. But this is not actually how things work in production, right? Because a lot of companies are struggling to put models into production. You can, of course, work on the batch model prediction. That's how machine learning or predictive analytics usually work in production, which means data scientists will train machine learning models, and then you sort of hand over the models to the software team or to some sort of data engineering teams to sort of automate or schedule the model prediction, right? So it does some sort of batch processing on a daily, weekly basis, or it could be hourly basis. It generates the batch prediction and save the prediction into the database somewhere, but the model doesn't need to be served in real time. This works for most of the data science use cases or machine learning use cases, because companies don't, or applications don't always need real-time prediction, right? But there's a clear, difference, or a line, right, drawn between the data science team and the model deployment team. So the data scientists usually don't touch any production code, and they give the model to the software, team or machine learning team, and then the models can be, developed in Python, but in production, the model might be, served using Java, for example, right? In production, this is how things work, right? If you would like to build a very robust machine learning and end-to-end machine learning solution, the amount of code we write, machine learning code, is actually not a lot. But there are a lot of other effort that goes into this, right? For example, having the right infrastructure, infrastructure as code. So you need to do a lot of configuration. If we would like to automate the ML model training, right? Because ideally we can automate the process, but that means the data collection, data ingestion, and also the data preparation steps will need to be automated as well. But whenever you automate things, things tend to break, right? So you need to have checkpoint, you have to check the quality of the data. And now we're setting up some sort of data pipelines or data lineage that has dependencies. That alone is pretty complex and you need data engineers to help. What if you're dealing with really massive amounts of data? So you can't load all the data into Pandas data frames, and you need, let's say Apache Spark or tools such as, Array, right? To sort of scale the data processing and model training as well. So that is very complex, but it's not something that data scientists can do on their own, right? Most of the time. And of course, models will need to be interpreted. The business and product team will need to understand them. A lot of times, data scientists will need to do visualization and explain the output to the business, especially the product team. So that is a lot of effort as well. And some companies will actually go to the extremes of building a lot of dashboards just to interpret the machine learning models, right? And then when we're launching, let's say Hadoop, Spark clusters so that we can process, large amounts of data, you need data infrastructure. Then if in a big company, you have, more than 100 data scientists and data engineers accessing the same infrastructure, we need to do resource management. And because everyone's sharing the cluster, so you don't get to take up 90% of the cluster resource, right? So resource management requires platform engineers or specialists who understand infrastructure really well. But that gets us to a point where we actually have the proper data infrastructure, right? The data warehouse, or the data that we need for machine learning, and of course, then data scientists or machine learning engineers can write the code in their Jupyter Notebook environment for experimentation. They built lots and lots of tools. And along the way, they want to keep track of their modeling process, right? Because for one modeling project, right, you might be working, changing the data input, doing all kinds of feature engineering, subsetting and slicing the data. It creates all kinds like different versions of the input data that you feed into your model training engine. And you're doing all kinds of tunings, trying all kinds of different algorithms. And very soon you realize that like you've created a lot of models and it's kind of hard to keep track of things. Or a machine learning engineer or data scientist who built the model 6 months ago, works great in production, but now he moved on to another job and you're tasked with sort of just improving the model or just revamping the model. And the first thing you need to do is, well, is there a way for us to reproduce the previous, model and the results? And then things are not always smooth and, not always well documented. And then you got frustrated because, you may not have the same working environment, right? You don't even have the training data set that was used for the modeling, by that machine learning engineer 6 months ago. And if you're going to recreate the modeling data set, and the data set might not be exactly the same because the logic may have changed or, the features and data has drifted, all kinds of issues. So reproducibility of your experiments is also very important, right? This is when tools such as MLflow come in handy. But finally, after all the experimentation, we've done all kinds of validation and testing, and we pick a model that we're comfortable with, right? Well, at this point, that's the data scientist's job. Now we need to deploy the model in production. When we deploy something into production, it gets more serious, right? So first of all, do we need some sort of real-time serving, right? If you're doing fraud detection, you're doing online advertising, doing click-through rate prediction, and website optimization, personalization. So a lot of these require, real-time, model serving. So you can generate prediction in real time based on the data you collected in the last few seconds and minutes, right? So that requires serving infrastructure, and model will need to be deployed, as an endpoint. But when we deploy some sort of small piece of software and API, then we have to worry about the scalability, the latency. This is a little bit more software engineering, and most of the data scientists traditionally are not very comfortable with this because they don't really come from software background, right? And to have a sound infrastructure supporting, let's say, your model, prediction, live prediction system, then we also need to make sure that we have CI/CD pipeline built. This is more on the DevOps side because data scientists will keep refining the models. But if we have created a model that and we've done some A/B testing, it works great, we would like to sort of replace this model, right? Deploy that into production, replace the model that's running in production. What is the deployment strategy, right? How often do we push the changes? And this is continuous CI/CD related concepts that MLOps team will definitely need to know how to handle. And once the model is being served in production, and we also need to monitor, right, your model performance in production, sometimes in real time as well. If you don't care about the real time monitoring, then at least I think we need to have some sort of batch process to generate the reports, and we need to constantly pay attention to if the data has drifted, right? If the data has changed, then we'll probably need to retrain the model. Or sometimes the upstream data preparation got screwed up. Right? If you don't have a very good testing, pipeline, then it's garbage in and garbage out. Right? So your model prediction is will stop making sense, and you want to be able to detect that. Otherwise the company might be losing a lot of money or losing customers. But sometimes you also need to do the real-time monitoring as well. That means you need to have the monitoring infrastructure in place, right? A lot of companies will be using Kubernetes, cluster, working with containerization, because when you look at the tech stack, you need Spark to scale your data processing, and you need Jupyter Notebook servers, you need or Jupyter Lab servers, and Python to train and tune models. And sometimes you want to do distributed training using Ray. When it comes to serving, you need servers for serving. Serving might be done in a different programming language, and then you have to set up Prometheus and Grafana, whatever monitoring tools. And these are all different tools and systems that consume different types of resources. You can't run all of them on one big server, right? So you're going to manage a lot of different servers. And the best way to do this is probably running this in production in a Kubernetes cluster. That requires infrastructure as code as well. So it gets pretty complicated, and then you'll realize that the time you spend on just training and tuning the model is actually not a lot compared to the end-to-end effort, and a lot of teams actually are involved in this, right? Okay, so that's machine learning engineering, and of course MLOps is a big part of ML engineering, and it is a little bit confusing because in some companies MLE basically deploy models and they work with infrastructure as well. But I think if you join a bigger team, these two roles are still well divided. Machine learning engineers will be training, retraining the models in Docker containers. They need to deploy endpoints, right? They may work on the serving as well, and also model monitoring. However, the MLOps is working more on the infrastructure, right? Scaling things, CI/CD as well. But I think if you're going through this, career transition or upskilling process, it will be great if you can learn both, and that's going to give you, a lot of advantage in the job market. Okay, so that's my understanding of machine learning engineering and MLOps. I'm going to dive a little deeper into that. So I have one slide that sort of explains the end-to-end process, right? And as you can see, it's pretty complex process. Let's start from the top, right? So let's say we have a machine learning engineer or MLOps project, and you need to initialize this, initiate this project. So it always comes from the business, right? Maybe the product team are launching a new product feature, which does some sort of personalization. So let's say personalized recommendation engine, right? So we start with the business problem, and then the architect, right, will need to be involved. What kind of tools are we going to use? How do we do the system design overall? What are some of the teams that needs to be involved? And then, of course, we need to define the type of models we need to build, the type of infrastructure we need, right? So these are business requirements, right? Budgeting, setting up the right team, okay? The next step, and of course, everything starts from data, right? Do we have the right data to support our machine learning project? We're not even talking about deploying that, because you need to have some sort of machine learning model prepared. And before you can train models, you need to have the data. So again, I think that's why machine learning engineers need to understand data engineering as well. Even though you're not building data warehouses, you're not building ETL pipelines, but part of the ML pipeline is actually data pipelining as well. So we need to identify the data sources, right? To support this kind of recommender system in production, what kind of data sources do we have, right? Of course, the company will have batch data, they'll have data stored in the data lake, in the databases, data coming from, third party, and some real-time data collected through their applications as well. And then we have to go through some sort of feature engineering pipeline, right? This is also kind of like data engineering, right? So you need to be able to extract data from the data lake or data warehouse. So that means sometimes you're writing Spark SQL jobs, or you're reading data directly from Amazon S3 or Google Cloud Storage using Apache Spark, or you might be using Python to do that. But we need to do the data pre-processing, right? So data cleaning, transformation. I think if you work in a big team, there might be data engineers who dedicate their time to this. But in some startup, you might actually just wear multiple hats. You will be writing the transformation code. You need to use Apache Airflow or Prefect to sort of automate this kind of data pipelines, right? And of course, there are feature requirements, as well. So we have to define the rules, understand the business logic, so we know how to transform the data. And most like this this starts with a batch process. But when you have the real-time data coming in, ingest it into your Kafka queues, and then data engineers or ML engineers might actually need to write Spark streaming code to process the data, right? So that's the data engineering part. We need to get the data and the feature ready, right? But I don't think the data engineers are the right team to do feature engineering. So feature engineering usually is done by the data scientist. But when it comes to automation, right, if you've identified some really useful features, you can send it to the data engineering team for automation. And in some companies, it's basically the machine learning engineer automating this as well. Okay. Well, let's assume that at this stage, the data we need for machine learning is ready, right? And we are going to start the modeling process, right? So this is where data scientists and machine learning engineers come in. If you have a bigger team, then data scientists will be sort of doing all kinds of experimentation. The data coming from the data engineer pipeline, right, can be saved in the feature store system in this case. But it doesn't have to be a production grade feature store, because a lot of companies just use a data warehouse, or you can store the data simply in an object store, such as Amazon S3. Right? It doesn't have to be a database. Data can just be stored in S3 as objects, but you can save that in feature stores such as Amazon SageMaker feature store. You can store that in Feast. There are lots of options, but I think before we do machine learning experimentation, you probably don't need to get the features into the production feature store. You can just store that in S3, and then data analysts and data scientists will start doing all kinds of data analysis, right? This is where you gain intuition about the data distribution, all kinds of issues in your data. That helps data scientists and machine learning engineers frame their ideas, right? How they would like to pre-process the data. Is it a data set that has lots and lots of categorical feature. So should we use cat boost instead of some other algorithms, or is it primarily, numeric features? Then does that mean we need to do a lot of binning? So we're talking about like, data, like machine learning strategies here, right? Because the data scientists will need to do the baseline modeling. And of course, there's, the data preparation, and then we start the model training. Now, training, validation, this is an iterative process. And data scientists will be doing all kinds of experimentation, and sometimes they want to keep track of the experiments they've done, because every model you build, there's some sort of input data, there's output, there's the models that you can save, and there are different versions, right? You can version control that as well. So using tools like, MLflow can be useful in this case. After we've done all kinds of experiments and we're happy with the model performance, now it's time to export the model, right? Because we need to save the model somewhere so it can be used by the production system. You can save the model to the model registry, right? There are all kinds of options here. You can use DVC, the data version control. You can save the model simply in Amazon S3, but you use a registry to keep track of that, right? But along with the model artifact, we're also saving the training code, right? The model training code, because in production, you may want to automate the model retraining process, okay? So you want to start doing not just the code version, like the model code version control, you want to version control the data as well, right? So you can reproduce the results. Okay, so at this stage, your model may have been saved into the model registry, right? And this is where the CI/CD kicks off, right? Because now we have the model training code, and sometimes we make changes to it, and we may update the model version, right? Every time when we save the model into, let's say, a registry, do we want to replace the model in production right away, right? And you don't just want to do this, blindly. You want to make sure you follow some sort of CI/CD process, right? Because that also involves the infrastructure side. You may want to rebuild your Docker image, right? So that it can be used by the production system. And then let's say we already have the model artifact, right? Everything's saved. We would like to start serving the model. We can, of course, do the batch processing. Then you can use Apache Airflow or some sort of workflow or orchestration tool to just run the scheduler, and then you're going to get the new data prepared every day, and then use the models, save the model to generate the prediction, and write the prediction back to some sort of production database, right? But if you would like to deploy the models in production, then we need the serving infrastructure, right? So we need to sort of deploy the model as an endpoint, right? You start to write API code. So that's model serving. But before we can serve the model, it's not just about saving the model and loading the model in production, right? We also need to get the feature prepared in real time as well. So the ML training pipeline, right? That piece of code needs to be deployed in production as well. So when we get live data, let's say from the online database, right? We want to make sure that the data is going through exactly the same process. Right? The data will get extracted. You're going to do feature engineering. Right? So that's the feature preparation, and then we're going to use the endpoint to generate the prediction, and that prediction gets fed into your live application. Okay, and along the way we need to do all kinds of monitoring as well, and this is a high-level introduction to how end-to-end machine learning system work. And of course, different companies will use different tools, right? This is just the process. But there are a lot of decision making we need to do. For example, what kind of tools do we use for data extraction and data transformation? Is your data really big? If your data is big, then maybe use Apache Spark, right? Does your data come in real time? Then we need some sort of infrastructure to process streaming data. So maybe data is ingested into Kafka. Then how do we consume the data from Kafka? right? Is it using Spark Streaming or using some other tool such as Flink? We need to make a decision on the feature store. What kind of feature store do we use? Is it going to be Feast? And how do we deploy that? Is it in GCP, in AWS, right? And what is the offline database? Are we going to use Snowflake or using PostgreSQL or using a NoSQL database, for example, to store your live features, right? If you're running recommender systems, I think Netflix uses Cassandra, but you also need to think about the caching layer, right? Because constantly hitting Cassandra, the latency is also pretty high. So using Redis caching, it helps you, scale the system much better. And then you have to sort of understand system design as well, right? And then for model training, during the model training experimentation stage, how do we track, the model training process? Are we going to use MLflow or some other tools? When we export the model, what is the format? Is it just going to be, scikit-learn and saving the model in the pickle format, which is probably not the best way? Or are we going to use Onyx, right? You have to decide the model format. And once you save the model, what is the registry you're going to use, right? How do we do version control of your model artifact and also training code, right? And when it comes to CI/CD, do we use Jenkins or do we just work with AWS, code pipeline and code deploy, or are we going to work with GitHub Actions? Right. So a lot of decisions we need to make, and looks like a lot of things we need to learn as well. When it comes to monitoring, there are many options as well. Model serving. Are we going to use Flask or a Fast API, or are we using Java? Right. So if you want to become machine learning engineers and MLOps, I think there are a lot of things you need to learn, but it's quite exciting because if you look at this, it's pretty complex, and it would be great if you have, you worked on a few jobs or worked for the same companies in different roles so that you get to work on something end to end in a couple of years. And then I think that'll make you a very, very good, machine learning expert. Yeah, and because I think it's very complex actually, and I don't think this part can be easily automated by ChatGPT because it's still just a language model. It's predicting the next word. It does it really, really well, but I don't think it can read them very well as well. And there are things like, Copilot. They can help you save a lot of effort, especially, giving you suggestions and save you time on writing a lot of the boilerplate code. But when it comes to an expert system, I think you still need a lot of, expertise and experience. ChatGPT simply doesn't have that kind of data for training. So I don't think it's that easy. So it excels at certain tasks for sure, at, for example, text summarization. But I don't think, the banks, insurance companies, or some companies are willing to feed the actual customer data into ChatGPT so it can learn from it. We're far from there. And there are all kinds of regulations, and a lot of companies don't even allow their employees to use ChatGPT, right? So the value of data scientists is definitely not writing, the 3-line, of, model training code, the dot fit, right? The train test split, and then the dot predict. That's something ChatGPT can automate for us, which is never, it's not the real value of a data scientist. It's actually analytics, right? So you actually need to look at the data, the pattern, and then make a lot of decisions for the company, and also you need to interpret the results to the business, and you need to do that very accurately. ChatGPT maybe can help you do that, to a point where you can, it achieves 80% of what you want to do, but that's far from enough, right? So here's my take on this automation. I think MLOps is harder if you would like to automate that. Another reason why it's harder to automate MLOps and MLE is that it really depends on the company's, decision-making process and all the legacy systems they have as well, and the team's expertise. If you have all Python developers on the team, you're most likely to go with Fast API or some sort of Python app. But if it's an engineering team that, people are all computer scientists, software developers, and engineers, they might be preferring C++ or Java, right? When it, especially for the banks, they all use Java. So they like Java developers, on the back end. So most likely your model is going to be deployed using Java app. And so because of that complexity, I don't think, this part can be easily automated. It's just like data engineering is also kind of hard to automate. Everyone know that, this is how you should replace missing value. Yeah, you can just write the code, but in reality, there are all kinds of reasons why some data is missing. It requires a lot of communications, and you simply can't automate that. And or at least we'll need someone to actually pay attention to the automation process. All right. So the learning path for MLOps and ML engineering. Let me break it down for you. This is actually WeCloud Data's machine learning engineering program curriculum, high level curriculum. We have this program is broken down into 2 different semesters. The first semester we focus on the machine learning side, right? So with a focus on deep learning. So we have a machine learning review for about 2 weeks to make sure that everyone's on the same page, right? Regarding, regression, classification, some of the classical machine learning, problems, feature engineering, model evaluation, how to build pipelines, to help everyone, get up to speed with the foundations. And then we start to introduce neural networks, and we teach in PyTorch. So we have a pretty big focus on PyTorch, and then we cover, all the nitty-gritties of neural networks, optimizations, optimizers, batch normalization, regularization, before we move on to the specialization. So we'll teach computer vision, convolutional neural network architectures, and then we'll cover use cases, object detection, segmentation, semantic segmentation, instance segmentation, and of course, transfer learning, and image augmentation and fine tuning. NLP is probably very hot right now. So, but we still cover the classical NLP techniques because I think it's still very important. So the traditional methods, word embeddings, sequence to sequence models, and then we move on to the attention models, transformers, and the generative models, which is quite exciting. And students also need to implement a mini version of the ChatGPT, the GPT model. And then student wanted to complete a capstone project in the first semester, and they can choose to specialize in NLP or computer vision. I don't think the student will have time to complete 2 projects because there's a lot we're covering, and then we'll quickly move on to the machine learning operations side. On the MLOps side, we sort of follow, 4 big, steps, right? Data engineering, model engineering, software engineering, as well as DevOps. So on the data engineering side, we don't have enough time in 6 months to cover everything, but we actually provide a self-paced learning course, which is what we call the ML Ops prep course. So the student will go through that in the first semester. So we cover Amazon Web Services, there's Apache Spark, data pipelines, feature store. We will cover that in the course. But most of the data engineering components, it will be self-paced, and then we have labs on Amazon Web Services. We're sort of getting students prepared for the second semester because everything is done in the AWS environment. So we use AWS heavily. On the model engineering side, we cover experimentation tracking, right? So ML flow, model packaging, how to work with model registry, and of course, we cover model serving and also testing. When it comes to model serving, then we need to cover, Docker, containerization. There are different ways to serve models in production. And of course, we need to, sort of containerize your application, model prediction, but we can deploy the models into, a serverless function, such as Amazon Lambda. You can build inference APIs using Fast API and Flask as well. So we cover all of these. And we also cover manage the tools such as Amazon SageMaker. And then we cover, unit testing. How do we test models in production? And then we move on to MLOps. There's quite a bit of effort spent on the DevOps side of things, such as how to build ML infrastructure. So we cover Kubernetes. So you need to build Kubernetes cluster yourself. And there's the Minikube version, but also the deploying Kubernetes in AWS, and using Helm chart to build your monitoring systems, such as deploy Prometheus and also Grafana for model monitoring, and also Kubeflow, which is covered as well. How to automate ML pipelines, and of course CI/CD. So we cover GitHub Actions and AWS code pipeline and code deploy. And cloud, on the infrastructure side, we cover CloudFormation, and a little bit Terraform as well. And of course, how do we deploy models in production? There are different deployment strategies. And once it's deployed, how do we monitor? So in the monitoring part, then we cover, feature and model drift. So what do we need to pay attention to when we deploy a machine learning model instead of just a regular software? And of course, the infrastructure monitoring, application monitoring is covered when we introduce Prometheus as well. But we also cover open source tools such as, Evidently, which recently become pretty popular. So these are the specialized tools that allow you to sort of monitor machine learning model performance in production. And then the student will be working on a capstone project. So they will most likely deploy whatever models they built in the first semester, and then deploy that in production using the cloud infrastructure. This is the curriculum that we follow, but we highly recommend everyone just to take this curriculum and set up a self-paced learning plan as well if you're not interested in boot camps. But definitely this is I think a structured curriculum we've discussed with a lot of instructors, and we've got input from industry experts as well. I think it's a pretty solid curriculum that you can follow if you like to do self-learning. And just to quickly summarize this, right? When you learn MLOps and ML engineering, we're not really separating these two. So we teach data engineering, model engineering, software engineering, and DevOps. So I'll pause here for a bit if you're interested in taking a screenshot. But the video will be uploaded to YouTube as well. Okay. All right. When you look at the tools landscape, it's very overwhelming. And on the data engineering side, there are all kinds of things I think you need to understand. You don't need to be expert in data engineering in order to become a machine learning engineer, but be ready to roll up your sleeves and write, automation, build data pipelines as well. I think when we build machine learning solutions, the first challenge we have, or not first, but there's always a challenge about label. So do we have the labels we need? So there's some options, right? You can work with a third-party company such as Scale.ai, which might be more expensive, Labelbox, but SageMaker has the labeling, tools as well. Where does data come from, right? If you work with a modern data stack, then most likely it's going to come from data lake, coming from warehouse, right? But those data are not always ready for machine learning. So I think ML engineers will definitely need to be ready to sort of write transformations and get the data ready as part of the data pre-processing and feature engineering process, right? And you need to use all kinds of tools. If the data is big, then Apache Spark, Ray, there's some options out there. If your company has, the workload heavily depends on Snowflake and data warehouse, you might want to use, dbt to automate the workflow for your machine learning purpose. Data governance is also very important, right? So Great Expectation is an open source project that you should definitely look into. And yeah, and also, where do we store these features, right? You don't always need very fancy solution, because I think um, we should be a minimalist when it comes to building a system. Just build whatever it takes that make it work, but you don't need the fanciest tool, because the cost might be really high. Sometimes it's the maintenance cost, or you're creating a lot of technical debt, and sometimes it's just the human cost, like, you just don't have enough talent on the team to work with these very complex open source tool. And whenever you put that in production, and you sort of have to, always keep, you're always on your toes, because things will break, and you know there are always bugs in these open source tools as well, right? That's the data engineering side. And on the model engineering side, I think in terms of the model training, if you come from a data science background, then you're definitely familiar with like PyTorch, TensorFlow, and scikit-learn. Ray is something I would highly recommend, because it's starting to become a very popular machine learning ecosystem on its own. It has distributed model training. It has Ray serve, right? Definitely look into that. Packaging, Onyx is very popular. Hyperparameter tuning, yeah, weights and biases, also popular for model experimentation, MLOps. But there are quite a few options here. Model registry, MLflow has model registry, DVC, and SageMaker has model registry as well. Or you can just build your own. It don't have to rely on these tools. On the software engineering side, you definitely need to learn how to do model serving. It could be as easy as just working with Amazon SageMaker, and then you don't have to write a lot of lines of code. But depending on your backend system, right? Sometimes you may want to use Fast API, but most likely you're building some sort of microservices, and you can deploy your models in a serverless fashion using Lambda and API gateway. It depends on the use case. It's not always the best solution though, right? And if your company happen to be working with Kubernetes, then you have the kubeflow option, Seldom as well. And yeah, on the DevOps side, infrastructure, version control, workflow automation, monitoring, and CI/CD. So there are quite a few things you need to learn. But I think it's quite a fun journey if you would like to become a machine learning engineer, because it looks like the skill set you're going to develop, it covers actually a lot of different areas. It's definitely good for your career. And later on, you can also switch to software engineering as well, if that's something you're interested. So I see people coming from data science, joining machine learning engineering, and then later on they can become software engineer. That could be a potential career path as well. And I think with all the ChatGPT large language models, there are a lot of opportunities for software engineers who would like to develop their AI skills, because even though it may replace a lot of the low level jobs, right, repetitive work jobs, it's just going to encourage more companies to start building, integrating with AI solutions. That means it's going to actually create more demand for backend engineers and software developers who actually know how to work with large language models. But you don't just call the ChatGPT API. Whenever you work, do something in production, you need someone who can fine tune these models to your industry, specific industry, problem. And you also need to do the MLOps, right? That's the part you can't skip. As long as you're building some sort of scalable, systems and software, you need MLOps, you need DevOps, and unless it's very easy, integration just with ChatGPT. But I think most of the companies, even if you start with ChatGPT API calls, you're going to build or collect user questions and answers. Eventually, you get enough data, you would like to fine tune these models for your industry, right? So I think there's a lot of opportunities actually. All right, I think that's all I want to cover today. And I hope this is useful. I would like to leave some time at the end for questions. So if you have any questions, feel free to ask. And for those of you who joined late, I'm sharing the links again. So you can join our Discord channel, follow us on YouTube. And if you're interested in boot camps, you can check out our machine learning engineering boot camp as well. What is the salary for an entry-level machine learning engineer? Depends on like where you're from, I guess. I think in Canada, it should be around, between 90,000 and 120,000 for an entry-level MI engineer position. It depends on your background as well. And I would say in the US, it should, well, big tech is always, an outlier here. But if we're just talking about machine learning engineer positions in general, instead of, because when you work for Facebook, the way you calculate total compensation is a little bit different. But if we're only talking about the base salary, I think for entry level machine learning engineers should still be around 100, between 120 and $150,000. However, when we say junior or entry-level machine learning engineer, I would like to point out, we're actually going to have a career session just to talk about job market. For machine learning engineers, most of the roles, even if it's like maybe junior level, they require like 3 to 5 years of experience. So that's why you sort of need to have a data science background already, or you come from a software background, or you just have really, really strong, skills and project experience. That's why it's not a very entry level job. Like if you get a machine learning engineer offer, that requires some experience, like at least 2 to 3 years. If you don't have many years of experience working as a data scientist, I think it's still possible, but you need to spend a lot of effort on just building really cool projects, because right now I think the demand is increasing, and the supply is not enough, to be honest. There are so many software engineers, but they're not necessarily trained in machine learning. And most of the data scientists, they can do the first 50%, but I don't think they are that familiar with MLOps and infrastructure data engineering yet. And that's why there's a pretty big gap in terms of the talent supply. So even if you don't have 3 years of experience, but if you have really, awesome project, portfolio, I think you'll still impress employers. So you have a good chance. In terms of the basic prerequisite, I think you need to have, let's see, definitely Python programming, because so you need to know packages such as pandas, right? Scikit-learn at the very least. You need to understand maybe just pandas, right? And then machine learning. So you need to understand the basic ML workflow. If you have never worked with machine learning before, I think you need to put some effort into sort of just getting yourself prepared for deep learning and computer vision and natural language processing. So having some experience with scikit-learn will definitely be helpful. And to understand neural networks, I think some linear algebra, so the math side is also important, but I think that's part of the prerequisite for data science and machine learning anyway. So yeah, I would say these are the prerequisite. And now to get prepared for MLOps, I would definitely say that you need to be familiar with Linux commands, right? Because when you work with Terraform, work with AWS infrastructure, you're going to write some command line. You don't need to be expert, but definitely you need to be comfortable with just running some commands and doing SSH, right? Copying files. So these are important, and the basic knowledge of Git. Yeah, on the data engineering side, it would be great if you know Apache Spark already. But this is something that you can learn, later on your own as well. I don't think you don't really have to have the Spark knowledge, but it's something that you should definitely pick up as well. Because when we do the job market analysis, looks like most of ML engineering jobs that will still require some knowledge about Apache Spark. Okay. Any other questions? How much math will I need? That's a good question. I think so when we're talking about math, then there's statistics, linear algebra, and some calculus, right? I would say on the statistics side, you definitely need to understand, things like distributions, right? Statistical sampling, hypothesis testing. But these are the necessary prerequisite for machine, like just data science as well. You definitely need to be very comfortable with vectors and matrices. You know, vector matrix, multiplication, dot products. Because when you work with neural networks, you'll notice that you're dealing with this a lot. When you start to write code, it doesn't matter that much. You just need to know enough math so you understand how things work under the hood and you're comfortable running those models, because you're less likely to sort of writing or designing a neural network from scratch. Most of the time we're leveraging, for example, the PyTorch libraries, right? It's more about getting the data right, getting the data augmented, and then we're applying different kind of algorithms and architecture to achieve our goal. For example, you're not going to retrain the generative model yourself. You're just leveraging that. Actually understanding how the tuning works is actually more important. So most likely at the beginning, stage of your journey, learning neural networks, then I think you need to understand linear algebra, statistics. But once you start to get more specialized in computer vision, natural language processing, I think the image augmentation, image processing, and just working with those unstructured data is actually another skill you need to have. It's not necessarily very mathy, but some sort of optimization you need to understand, like from a calculus perspective, calculating partial derivatives and doing like gradient descent and things like that. Okay. Any other questions? Alejandro has some questions about the projects. So how to build skill on MLOps once completing a postgrad program in AI and ML. So if you have completed a postgrad program on AI and ML, I'm assuming that you're very comfortable with, deep learning, PyTorch, and data processing in general. I think my recommendation in terms of the projects. Oh, actually, I forgot to talk about the projects. So when you build portfolio projects, first of all, I wouldn't recommend you to purely focus on MLOps, the infrastructure side, because when most of the companies, like, I think this is like the data scientist, data science 10 years ago. Companies just want a data scientist, but they hope that they can do everything, right? And then 10 years later, we realize that, well, now companies start to specialize, right? Data scientists, they need like, some of the data scientists basically work in data analytics in general. They're data analysts now. And there are data scientists who focus on predictive modeling, experimentation, storytelling. But then there's also ML engineers who specialize more in the machine learning model tunings and engineering side of things, right? I think it's the same for ML engineering. If you look at the job postings, they want you to understand infrastructure, but they also want you to know TensorFlow, PyTorch, model tuning. They want you to know everything. So when you prepare your portfolio, I would recommend actually, you still need to have some machine learning and deep learning projects in your portfolio, right? You need to have at least, I would say 1 to 2 ML projects, or you can call that AI projects, right? But you need to have some sort of, I would recommend, let's say, one like structured, right, data set, right? It could be, data set coming from, because most of the companies are still dealing with very structured data. Like if we're talking about retail, right, telecommunication, insurance, healthcare, a lot of these data are structured. So if your portfolio only has image and text data, it's going to put you in disadvantage, as a lot of the companies are looking for people who have experience working with structured data, right? And the way you handle like computer vision problems is very different from the way you do, for example, feature engineering for structured data, right? And focus on feature engineering. I think that's still very important, right? And the end-to-end workflow, right? And then you should have one to two, right, specialized projects. So work on whatever you think is cool. NLP, computer vision, actually 2, right? And then maybe just choose one specialized project. And then you add the one MLOps project that actually allows you to train and deploy the models, right, in production, build the infrastructure for it, and create CI/CD pipeline, right? I think if we can do this, that'll be very impressive. But of course, I skipped a lot of details. But it would be nice if we can have 1 to 2 MLOps project as well. But don't forget about the machine learning part, because that's what many companies are asking for. Oh, I can give you some project ideas. For example, I remember I was talking to a student in the current cohort. He's actually interested in computer vision. So his semester 1 project is actually we always recommend students to do something end to end. So try not to download a data set from Kaggle. He's collecting his own data. So he's collecting highway traffic data, and he found a real-time API. I guess near real time, that generates sends the traffic data, I think once every minute or every 5 minutes. And he's basically doing object detection, right? And he detects all the cars using YOLO, but then he's feeding that into another predictive model, which is predicting the traffic congestion, right? So that's what he did in his first semester. And then the second semester, he's actually trying to deploy that in production. He developed an endpoint, but he's also building some sort of front end. He's not a front end engineer, so he's looking into some sort of open source tools that allows him to build the front end easily. Things like Streamlit, but he's building he's deploying his models in the back end, right, and writing all of those logic. I think it's a pretty cool project because he has the data ingestion part, right? And he has to figure out how to label some of those data, and then either leveraging the YOLO API or just training his own model and do some fine tuning. And then he deployed the model as an endpoint. He set up the CI/CD pipeline. The CI/CD pipeline is not just for his model training deployment. It's also the actual application that does the traffic, prediction, traffic prediction. So that is an end-to-end project, which is pretty cool. So hopefully this gives you some idea. Sure. Oh, the existing link seems to have expired. Let me give me 1 second. Oh, my bad. Okay, let me reshare link. I'll get that next. Any other questions? There's a question. Can you please share a well-written portfolio or CV with us? Yeah, we have a session, I think next week or maybe the week after. We are doing the job market, and the search. So I will discuss, how to write a resume for data science and machine learning, positions. So definitely stay tuned. I will cover how to write portfolio and how to write, CV. Okay, this is a temporary link. Okay. If you are at the beginning of your learning, like your data science or machine learning journey, and you would like to learn Python, you can go to learn.weclouddata.com. So we have something called WeCloudOpen. So you can have access to our free Python and SQL self-paced learning courses. We also have, workshops, DevOps engineering, data engineering. In DevOps, I think we had some sessions on Terraform, uh, Ansible, GitHub Actions. So there are recordings as well as lab material. So definitely take advantage of it. There was a question about cybersecurity. We don't really cover anything related to cybersecurity in this course. On the security side, I wouldn't say this is security related, but we do cover model bias and fairness, which is a pretty popular topic nowadays, especially in a lot of the highly regulated industries. So that's an important topic in deep learning and machine learning as well. But nothing related to cybersecurity. Okay, seems like there are no more questions. If you would like to stay in touch, definitely join our Discord channel. And we post all of our events in this channel. So you can go to events. I think we have 12 events posted. And some of those are DevOps related. Some of those are BI, data science. And I think we should have some machine learning engineering events in the next 2 months. So we'll have panel discussions. We'll have more career talks, and also we have sessions dedicated to job search, resume, as well as how to build portfolio projects. And you'll get to talk to some of the alumni as well. So I look forward to seeing everyone in the future events. And I hope you have a